Hello, this is chapter 15, exercise 26. It says you are testing the null hypothesis mu equals 0 against the alternate hypothesis mu is not equal to 0 based on a simple random sample of 20 observations from a normal population. What values of the z statistic are statistically significant at alpha equals 0.005 level? All right, so and then there's three choices here: values z greater than 2.576, et cetera, et cetera. All right. So first of all, let's draw a picture of what's going on here. So we've got a normal population, therefore we can assume the sample and that sigma is, we're assuming sigma is known. This is chapter 15, so we'll have a normal sampling distribution as well. All right, now we don't know what mu actually is, but we're assuming for hypothesizing purposes here that mu equals 0 and that the alternate is mu is not equal to 0, and eventually we have to pick one of these hypotheses. All right, so 0 is right there in the middle of the sampling distribution. So you take a sample, random sample of size 20, and if you're lucky, if mu really equals 0 and your sample is exactly the same as the population mean, then your sample mean is exactly 0. But of course, there's always that natural sampling variation that happens, and so the real x bar could be positive something or negative something. Now, in this question, they're not asking us to do a hypothesis test, but it's in the context of a hypothesis test. So in a hypothesis test, step 1, write your hypotheses. Step 2 is you get your data, you get your x bar, but we don't know what that is. We get our standard deviation of the population, which we don't know that either. And we do know n is 20. Okay, and then you go on to step 3, which is you do those calculations, you do sigma over square root of n, but we don't know what that is, except we know n is 20. And you get your z-score, and z-score is blah, 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 whatever it is. The formula x bar minus mu from the null hypothesis over sigma over square root of n. But we don't know what it is. But the question is, what does this z-score have to be? What do the results of this calculation have to be so that you reject the null hypothesis? Let's go back to the original wording of the question here. It says, what values of the z statistic are statistically significant at the alpha equals 0.005? In other words, what is going to make your p-value be less than 0.005? All right, so the p-value, whatever it is, we don't know what it's going to be, but it should be, if we want to have significance here, should be less than 0.005. And that's because the rule that says if the p-value is less than alpha, then you reject that null hypothesis. That's the rule that we're going by. And if you reject the null, that means you have found significance. Okay, so we can just rephrase this question to, instead of what values of z, let's go back to the question here. Instead of saying what values of the z statistic are statistically significant at the alpha equals 0.005 level, it's exactly the same as asking what z-score would give you a p-value less than 0.005. Okay, now we have one extra little complication here, and that is we've got ourselves a two-tailed test right here. So remember, you take that p-value and times by 2 for the final p-value. So let's go back to our picture of a normal curve here. It means that this area up here plus this area down here, that area should be less than 0.005. So let's just pretend for a minute that the p-value is exactly 0.005. Let's just say we got a particular z-score that gave us exactly 0.005. Since it's a two-tailed test, that means this 0.005 has to be split up evenly. So 0.0025 is that area down there. 0.0025 is this area up there. So now let's rephrase the question here. Let's start over here. So what z-score produces a p-value 0.0025. So now let's just take a look at one of the tails. So here's our normal curve. So let's do the negative end because it's easier on the table to find the negative numbers. You don't have to worry about subtracting from 1. Okay, so what is that z-score that gives you 0.0025, which then when you times by 2 would give you the 0.05 that we ultimately want right there. All right, so to get that answer, what is that z-score? You have to go to the table and use it backwards. So I've got the table right here, and here's all of our numbers. So find the z-score that gives you 0.0025. So let's just search here. I've got 0021. I've got 0028. I'm still looking. Here we go, 0024. Here it is, right there. Oops, I just want to highlight the 1. Oh, hold on here. Okay, there. I highlighted. There it is, 0.0025. And what is the z-score that gave us 0.0025? That is negative 2.81 right there. So that's our z-score. Z is negative 2.81. So in other words, back to the original situation here. So if you do a hypothesis test, here's your null alternate. You get your x bar, blah blah blah. You do all those steps, and then you get z-score. And if you do this calculation, and you end up with a negative 2.81, then when you look that number up on the table, you'll get negative 2.81. You look it up, you'll get a 0.0025 down there. And because it's a two-tailed test, you times it by 2, and you, times 2 equals 0.005. And so there's the answer to our question. Now, it's a two-tailed test, so z also could have been positive 2.81 as well. That would have just given us the 0.0025 up on the upper end. And that's perfectly fine. On a two-tailed test, lower or upper are both fine. Okay, so now let's go back to the question. It's a multiple choice question, so find the answer that's as close as we can to 2.81. So here's the original question. Okay, so option A, all values for which z is greater than 2.576. No, that's 2.81 is what we're looking for, so that's not it. Okay, B, all values for which z is greater than 2.807. Well, 2.807, if you round off, is 2.81. But that's only for positive numbers. So it's closer, but it's not quite right, because z could be negative 2.81 or 2.807, and that would work as well. So B is close, but not quite. So it has to be C. All values for which the absolute value of z is greater than 2.807, or rounded off, 2.81. That's what our table gave us, 2.81. So that means if z is negative, the absolute value of it is still going to be greater than 2.807. And so there's your answer, is option C, right there. And in general, this is a handy trick with two-tailed problems here, is if you want z to be, well, all right, let's start from the beginning here. If you want z to be, I'm going to round off 2.81. If you want z to be greater than 2.81, or you want z to be less than negative 2.81, because it's a two-tailed test, that means less than negative 2.81 or greater than 2.81. You can combine that together into one handy little phrase or sentence here. The absolute value of z must be greater than 2.81. So option C is the answer.